Today we study vector space. Vector space. Okay, what is vector space? Space is a non-empty set V with two operations, say addition and dot. So when we say कि there is two operation plus addition and dot multiplication, we also know about these operation. As you know that when this operation addition applied on R means you can add any two real numbers, say 2 plus 3 gives you 5, 3 plus 5 gives you 8. But actually what is addition? This is a map. How you can see it as a map? Actually, this operation plus is a map which is from R cross R to R. Here, a number 3 is a member of this R, and again 5 belongs to R, means these are two real numbers, and 3 and 5 maps to a number 8 that is also a real number. Similarly, what is dot? Dot is also operation. It maps from R cross R to R. Suppose 3 is here and 5 is here, then the two real numbers 3 and 5, which are the members of 3, this is the ordered pair 3, 5, and it belongs to R cross R, and dot operation means the multiplication operation maps to this operation as 3 dot 5 is equal to 15. So here we have a non-empty set V embodied with two operations, addition and dot, and this V is a vector space defined over a field F. We will discuss the properties of field later on. First we know what this addition operation and the multiplication operation is defined on V. The addition operation is defined from V cross V to V. It means this operation is a map from V cross V to V. That is, any two members, say U and V, belonging to V cross V maps to V. Say U comma V maps to U plus V. This belongs to V and this pair belongs to V cross V. So what is plus? Plus means the addition operation. This maps from V cross V to V. That is, any ordered pair in V cross V is mapped again on an element of V. The members of V are called vectors, and this operation addition is called the vector addition. Our next operation is dot. Dot we simply represent here it as dot, but actually it is a scalar multiplication. Why it is called a scalar? Because this operation maps from F cross V to V. That is, if A or alpha is a member of F, V is a member of capital V, that is our space, and it maps to alpha dot V. Or simply we say alpha V, this ordered pair, maps to alpha V. Now with these two operations, what are these operations? Vector addition and scalar multiplication. This is also called internal operation, and this is called the external, and this is called the internal operation. Now with this operation, that is called the vector addition. What is called? Vector addition. Now we learn about the properties of this operation, vector addition. First property is the closure property. Closure properties means two elements u and v that belongs to v cross v is always maps to a single element v. The definition of scalar vector addition also defines that this v with respect to this operation plus is closed. That is, addition operation is closed in v. First one is the property of associativity. Associative property. What this properties mean? If u, v and w belongs to v, then u plus v plus w is same as u plus v plus w. You all are familiar with this property. This is called the associativity. And third property is the existence of identity. This identity is called the additive identity. Because operation is addition, so this is called the additive identity. How this identity work? If u belongs to v, then there exists an element e such that u plus e is equal to e plus u. You can verify that e is 0 here. So what is additive identity here is the 0. Means u plus 0 is equal to 0 plus u is equal to u. So 0 is here the additive identity. So third property is the existence of the additive identity. Fourth property is the existence of inverse. Existence of inverse. What is this inverse? Is obviously called the additive inverse. For example, if u belongs to v, then there exists an element u inverse or simply minus u such that when this element, that is u, is added with its inverse, it gives you the identity element. Obviously, when you solve, you find u inverse is minus u. So whenever u is in v, then minus u always belongs to v. So every element in v has a additive inverse. Minus u belongs to v. So there always exists a inverse in v. Fifth property is the commutative property. Commutative property. So what is this commutative property? Suppose we have three elements u, v and w belongs to v. Two elements. We have two elements u, v belongs to v. If we change the order of operation, u plus v is same as v plus u. This property is also called the abelian property. So the commutative property hold in v with respect to operation vector addition. So v with respect to this operation addition or vector addition forms a group. These 5 properties give the group structure of the v. It means v plus is a group. Next, these properties are associated with a scalar multiplication. Scalar multiplication satisfy the following properties. First, a u plus v is equal to au plus av. You very well know that this is the distributive law. Here a is a member of field f and u and v are the vectors. U and v are the vectors. So a scalar, members of the field are called scalars. So a scalar distribute over the addition operation, vector addition operation in v. So the first property is a distributes over u plus v. Next property is A plus B U equal to AU plus BV, where A, B are the members of field F and UV belongs to vector space, UV belongs to V. Next property is A plus B Next property is A plus B V is equal to AU plus BV, where AB belongs to field, that means A and B are scalars and U and V are vectors. They belongs to V. Next property is very simple. A BU is equal to ABU. If we change the order of application of scalars on vectors, then the product remains the same. Here again, AB are the scalars, they belongs to F, and U and V are the vectors, they belongs to V. Next property is 1 operated on U is equal to U, where 1 is the multiplicative identity in F. So 1 belongs to F and U belongs to V. So with these properties, 4 properties here and the 5 properties of the grouping property of the V is what? V is a non-empty set. So this non-empty set V with 2 operation. First one is vector addition and second one is scalar multiplication. Forms a vector space V. Elements of V are called vectors and the members of field F are called scalars. So V is a vector space over a field F together with 2 operations, vector addition and scalar multiplication, is called a vector space if all these properties listed here, first one is the closure property, associative property, identity property, inverse, existence of inverse, commutative property, and these 4 properties with respect to scalar product satisfied in V.